So today I will take your control unit design. Okay, beta. And most probably Bibhas sir has taken few classes, but I would like to start my own way. And so this is your basic computer system. Already you know. Any computer has these components, that is central processing unit, memory unit, input and output units, and main central processing units already you have studied, that is the execution unit, and another part, that is the control unit. So what is the basic difference between execution unit and control unit? That is the for execution unit, mainly it has all processing components. That if you do the addition, subtraction, multiplication like this, or shifting operation, comparison, these operations can be done with the help of execution unit. And when it will execute, that depends on the control signal and the time at which time it will be executed. So control signals basically generates from the control unit, and at the same time at which time it will be generated, that will be controlled by the control unit. So control unit has the two tasks. One is that generates the control signal, another is that at which time it will be executed. This is the basic thing for your control unit. Now whatever the operations that how processor can understand that what is the meaning, on that moment control unit that helps to find out the meaning, and that depends on that it will generate the signals. And if it wants to execute any operations on that, any operations or any instruction execution, whatever it is, that is basically a set of operations. Okay. And if all these operations, that means a set of operations, when it will be executed, that should be in a right sequence. If sequence is not in proper way, on that moment you cannot get the correct result, isn't it? Now you have studied the different types of the you can say that computer system, or you can say that processing unit, or processor you have, if you want to design. On that moment you may have the register based machine, you may have the stack based machine, or you may have the accumulator based machine, but whatever the machine, that that has the set of instructions. Okay. Now here I have considered the very simple instruction, that is add B from 8085 microprocessor, because it is a very simple, you know that 8085 microprocessor instruction set is very simple. Now, whatever the instructions, that may be the arithmetic operation instruction, that may be the logical operation instruction, that may be the move instruction, that means data transfer instruction, that may be the branching instruction, whatever the instruction, if you understand that what are the steps are used to execute that instruction, there you can see that most of the sub operations are involved the data transfer operation. Okay. So here I give one example, that is the add B. What is the meaning? Addition of A and B, content of accumulator and content of register B, it will be added and then it will be transferred to A. So what are the operations, sub operations you can have? So first it will be transferred the data from register B to so first it will transfer the register B to temporary register, then it will add, after addition it will transfer again the data to the accumulator. So most of the operation is the register transfer operation. So for that reason, what we can do, we can consider some basic examples where you can have that type of the data transfer operation. Now, first example, if you consider only the transfer the data from A to B, on that moment, what you can do, you can design a register A, you can design a register B, depends on the size. Here I have considered the 8-bit. So here A is the 8-bit and B also the 8-bit. So 8-bit data can be transferred from register A to B. Now for the first, it is you don't have any control signal, or you don't have the any you can say that any timing any timing at which time it will be executed. That type of information you don't have for this notation. So it is a very simple, only transfer the data from A to B. So it is very, so it is, design is also very simple. Now for the second example, see that here I have included one enable line. That means that is a control signal. Basically this is a control signal. So based on this control signal, the data will be transferred from A to B. Now now, how you can do this thing? It is a very simple meaning. That is, when E equals to 1, on that moment, it will be transferred from A to B. And if it is 0, on that moment, B equals to B. That means data will not be transferred from A to B. Whatever the data of B, that will be goes to again into the B. So how you can implement? See this, here the basic diagram. With the help of multiplexer, we can control this data movement operation. Now D flip-flop is used to store the data to the B, and here B A to B, that means AI, that means only one bit we are trying to store with the help of the D flip-flop. Okay, and how you can control that is depends on the E. Now see that this two diagram is very simple. E is 0 on that moment. See that B value will be again go to the input to the marks and again come to the D flip-flop. That means B goes to B. Now if E equals to 1, on that moment what is happen? Second line, second input, that data can be goes to the input to the D flip-flop. So what is the second input? Second input comes from your second input comes from your, that is A, register A. So A, from the register A to that register D, that means goes to register B. So here depends on the enable line, we can transfer the data from A to D. So control signal here is the E, and what is the data path? That is, you can say that I have mentioned with the help of, that is the blue line. Okay. Now I hope you don't have any problem. It is a simple structure. With the help of multiplexer, we can control the data transfer from A to B. Now suppose another example, little bit complicated. Now see that what is the instruction? If A greater than B and D 0 equals to 0, then transfer the data from B to A. Now, so what are the registers are required to implement this? So here 3 registers are required, A, B and D. Now here from the D register only we will consider the last bit, that is a D0. And what are the data transfer? Data transfer operation only done between the B and A register. Okay, so it will go to B to A. So here I have done mistake beta. Okay, so first register should be B and second register should be A. Clear? Here I have done mistake. I hope you understand this. This should be B and this should be A. Otherwise, this cannot be done. Clear? Now, A greater than B, that you can implement with the help of comparator circuit. And after that, you can combine with the help of the logical AND operation, and you can generate one control signal. Okay. Now see this design. How you can do? Here I have done correct. Okay, B to A. Now, A greater than B, that depends on the values of A and B. So, one data comes from registered A, another data comes from registered B, and it will compare with the help of the comparator circuit. Depends on the registered A and B, that bit of comparator you have to design, and another register D. So from the last from the LSB, you have the one bit, and with the help of the logical AND, you can generate the control signal. And when it will be 1, on that moment it will transfer from B to A, and if it is 0, on that moment A goes to the A. So whatever the previous circuit you have designed, that you have to implement here with the help of the multiplexer. Clear? Now, another example, that is a, if x equals to 0 and t equals to 1, then you transfer B to A, and if x equals to 0 and t equals to 1 is not true, on that moment transfer from register D to register A. So what are the basic components we need to design? That is a register A, B and D. Okay, 3 registers are required to design this type of the problem. Now, what are the data paths? First, you have to find out the proper data paths. Otherwise, you cannot place your control lines. Now, registered B and D, you can understand, transfer to the register A. And register A will be controlled, depends on the X and T. Okay. So now, if I design in this way, that is a x equals to 0 and t equals to 1. So obviously C equals to x by t. Here it is, these two conditions are combined with the AND. So logical AND operation will be there. So C equals to x by t. Now it is very simple. Only we can write into the select line, that is a control bit we can give with the help of the value of x and t. Okay, so with the help of x and t, easily we can transfer the value from B to A and D to A. So I hope these problems you can easily solve. Do you have any question, Peter? You can design yourself this.
Yes, ma'am.
Do you have any question? Projota, Abhishek.
Ma'am, no questions in particular, ma'am.
How, Peter?
No questions in particular, ma'am. No
Okay.
questions in particular.
So these are the first assignment. Please you do that. Okay. This is very simple. First step is that what are the processing units are required. Second step is that what are the data paths. Data paths are very, very important. Then had to find out where you have to place the control signal, and that control signal depends on what parameters. Okay, so in this way you can design the total unit. Now I will next class again I will explain the control unit. Today little bit I will go to your previous class. See that this is a shift register already you have done. I have told you please solve this barrel shift register. Anyone can explain this barrel register? Basic logic, anybody can explain better? You have not prepared.
1 second, ma'am. Just checking the notes once for once, ma'am.
I have told you, please you solve this problem. That is 16 by 60. It is very simple, but looks like very complex. Okay, fine.
Yes, on the combinational shift register, ma'am. Yes, ma'am.
Combinational shift register, 16 by 16.
Yes, ma'am. Ma'am,
So,
yes, ma'am, I'm done it halfway, ma'am. I've done it halfway, ma'am. Didn't complete the entire thing, ma'am, but I got the main concept of it.
so what is the basic concept to design this better? Can you say? Yes,
Ma'am,
this is the algorithm.
basically cascading, ma'am.
Huh?
Ma'am, basically, 16 by 16 shift, barrel shifter means that, like, since it's 2 to the power 4, ma'am, so in
Hmm.
that case, there will be 4 inputs.
Yeah. So your truth table will be like this, rotating. So whenever it is all zeros, so you have all the 16 bit from x0 to x15. So 001, that means the one time it will be left shift. In this way, if you have the 15 times it will be the left shift. Clear? So what is the logic? Logic is very simple. Suppose if you have the number, sorry. Suppose if you have the number 1101, okay, this number you can write in this fashion, that is I plus 4k. What is the I? This if you consider the I, and this if you consider the k, on that moment what will be happen? 01 plus 4 into 1 means 3. What will be happen? 1 plus 12, that is a 13. So 1101 is 13. So with the help of this basic concept, the barrel shift register is designed. So for the first time, it is the I, then it will shift the 4 times to the K. It design the barrel register. Ultimately, you have the value Y. Clear? So see that diagram, then you can understand. With the help of this basic concept, it has designed. Now see that for the 00, for the 00, you have the x0 here. So 1101, you have the 1101. That means you have the y13. Where is that? Sorry, 8 plus 4 plus 1, y13. Y13, you have the, where is the y13 beta? Here you have. Clear? Now, how you can have the design? See that. So for the first part, whatever the, if it is the 000, then it will be normally you have from x0 to x15. Clear? Now for the next time, what is happened? See that b0 is entered here, b1 is here, b2 here, b3 here. So b4, here is the b5, b6, b7. So it shifts to the left. In this way, it will place into the second level. So from that, you can have the value of x0 in here. That is a y13. Where is the y13? That is a y02, where you have, here you have the y13. Okay. 13, 14, 15. Here you will have the y13. Y13, in the help of the y13, you can have the x0 value. So this concept is very simple, but how you organize the inputs, that depends on the concept, that is a I plus 4k. Because if I do the I plus 4k, automatically we can shift that times of the of your inputs. Okay. So I hope you understand. You can practice. You can just take some other examples and check that what is happened. I hope you can understand then. Now next is that I have told you. Please try to find out the different uh, delay time. What is the time will be required to execute the ripple carry adder, and what will be the time will be required to compute the uh, addition value with the help of carry look ahead adder circuit. Have you done better this, Prajuta?
Not this one, ma'am.
No. Okay. See that I give one hints to you, huh? You please you complete better. Because of that, a little bit it is not very tough, but if you don't practice, you cannot write. Okay. So see here, if you observe here, from C, if you want to get the value of S, then if you consider from here to here, time delta or delay is delta, and from here to here it will take another delta, and from here to here it will take the time, that is a delay, that is delta. So we can say it will require the t delta time. Okay. Now for the C, if you from the C0 to C1 or C1 to C2, whatever it is, it will only require the 2 delta time, because it is an AND OR structure. So from here to here it will delta time, and from here to here it will require the another delta time. So you will require the 2 delta time. Clear? Now suppose if you need the 16-bit ripple carry adder, if you want to execute, so what you will do, that from C0 to, you can say that C15. Okay, so from here you need the 15 into 2 delta t time will be required, and from C15 to last bit S15 or S15 or S16, sorry, on that moment you need the 3 delta t time. Okay, so ultimately you will have the 33 delta time. In this fashion you can compute the total delay. Okay, that depends on the structure of your address circuit. Now if you use the, suppose if you want to consider the carry look ahead address circuit, what will be happen? Here you can see that C4, and here is the C0, and it is a, you can implement with the help of AND OR structure. Clear? So AND OR logic, whenever you use, you can see that is a 2-level circuit. Okay, if it is a 2-level circuit, on that moment you can see that 2 delta t time will be required. So if you draw the 16-bit different way, you can design the 16-bit address circuit. Now if you design in this fashion, that first if you 4-bit carry look ahead address circuit, so if you place all the x and y, and here you can have all the a's, and here if you place the C0, here you have the C4. Now another same type of component, suppose if you consider the 4, and here all you connected in a ripple carry fashion, on that moment what will be happen, from here to here it will be required the 2 delta t time, from here to here it will be required the 2 delta t time, from here to here it will be required the 2 delta t time, and here to here it will be required the 2 delta t time. Okay, so 4 into 2 delta t time will be required. But for the last case, when you have, if you want to get the value of S15 or S16, whatever it is, last summation bit, if you want to get, on that moment you need the 3 delta time, because for the carry looker address circuit also, for the last case when you want to find out the A's, that depends on the X, Y or GI, PI and CI. Okay, you can design the circuit with the help of GI, PI, CI, or you can design XI, YI and CI, because both are for both the cases you can have the same result. So whatever the logic you can consider, but whatever the logic you could consider, so if you want to design this type of the expression, on that moment you need the 3 delta time. So here you need the 4 into 2 delta and plus 3 delta. This is the required to design the 16-bit adder circuit. Okay, I have given this assignment or not. I will check that first. What type of assignment I have given? That design the circuit. Okay, so another way you can design. Okay, you try to use the author Hayes. Very nice structure is that. The first design I have told with the help of the ripple carry adder, but you can design another way. That is a carry look adder circuit you can use, and you know that different G0 P0, in this you can use for designing the totally CLA based design. Okay, so for that the time requirement will be different. So depends on the structure what you will consider. Based on that you can compute the time. Please you design these 3 circuit with the help of the different way, not only use only the single way. Okay, so 4-bit carry look adder circuit you can use in different fashion. So Please you study from the Rafiquzzaman, and very nice way author Hayes also explained. So that circuit also you can consider. Clear, beta? Please study, because most probably you will have the mid-same.
Yes, sir. Ma'am, could you send the last part of these notes from page 15, I guess, ma'am, because we have till page 15 in the
Just wait,
slides.
beta. Oh, sorry. This part? No, previous
Actually,
circuit.
yes, ma'am. Yes, ma'am. The previous one also, ma'am, and in execution unit, ma'am, we have till page number 15. Like there are 15 pages in the slides, ma'am. Like the
15.
last topic that has been taught is array multiplier and restoring division algorithm. We don't have the circuits for 16-bit and all those ones.
That is a multiplication algorithm. Projita?
Wait, ma'am. Let me check one second. Let me check it out. I guess I missed that out in that case.
Okay, next class I will explain that.
Okay, ma'am.
Okay, so if I will request all of you, if you have any doubts, please you will tell me, and with the help of your WhatsApp, or you can write the mail, huh? Because you have exam. Now today I would like to stop here. No, sorry, I have given the many other assignment I have given to you. Please you complete better. See this. You have done this.
Which one, ma'am?
Which one? This part better, serial adder, different way you have to design.
Are you sharing your screen, ma'am? Because it's not showing.
I have shared better.
Ma'am, it's showing, ma'am. Ma'am, we haven't received these notes, ma'am. This is what I was saying, ma'am. We haven't received these
Sujata,
portions of the notes.
your voice is not coming well. Just wait, just a minute. What has happened? I could not listen properly. Yes, what you are asking, Projota?
Ma'am, that is what I was saying, ma'am. Ma'am, we haven't received these notes, ma'am.
Oh, I have uploaded most probably better.
Ma'am, I'll check one second, ma'am. 1 second.
Yeah, I have done better.
Is it on Teams, ma'am? Is it on Teams? The files
Ha
in
ha
Teams,
ha
ma'am?
ha. Okay, again I will give you through your WhatsApp. Okay, please you complete. Otherwise, it is very difficult. You will have many assignments at a time, then you cannot complete.
Yes, ma'am. Okay, ma'am.
Clear?
Okay,
Another
ma'am.
very simple design I want to explain. It is known to you. You have done in the last semester the digital electronics class. So, but here it is designed in different way. That is the LU design. Oh, I could not control the. See that in your last semester, what you have done, arithmetic logic unit design. There, what you can do, you can use initially the marks, and that and with the help of these marks you can use the 4-bit adder, and this adder, whatever the inputs, that you can control with the help of this select lines. Okay, so in this way you have designed. But here what is the basic concept is used. uh, we want to design the ALU. So first target is that design the arithmetic unit, then design the logic unit, then it combined these two, and ultimately with the help of the multiplexer we get the result. Clear? It is a very easy circuit. Now for the arithmetic unit circuit, see that here it is coming the one of the input, 4 input data, and here it comes the another 4 input data, and this 4 input data will be controlled by the S. If S0 is 0, on that moment it will be the add operation. That means whatever the value of B, that will be coming to here. Sorry, here it is considered the Y. So whatever the value of Y, that will be coming to the this with the help of this lines coming to the input of the 4-bit parallel adder, and it will do the addition operation. But when it is the 1, then see that with the help of the NOT gate you can have the Y complement. So we know that what is the A minus B? What is the operation? That is A plus 2's complement of B. So what is the 2's complement of B? That means A plus B's complement plus 1. So in this fashion, with the help of this algorithm, you can say, or with the help of these steps, you can do the A plus B and also A minus B. And here for the logical unit, what has happened? It considered the 4-bit logical AND operation and 4-bit logical, you can say that, exclusive OR operation. So it is controlled with the help of the S0 value. S0 is 0. On that moment, 4-bit, you have the logical AND value. If it is 1, on that moment, you will have the logical exclusive OR operation. Clear? So this is very simple circuit, and how it is merged. Take that. See that how it can be merged. Now arithmetic unit, here is the logical unit, and use the multiplexer. And for the first two cases you have seen, only use the single select line, and it is a that with the help of this it can transfer the data, or it can do the execution, and it gives the output with the help of the arithmetic unit and logic unit. And what value will be transferred from here to here, that depends on the S1. Now suppose if I give the value 0 0, on that when what will be happen? It is 0, so it will be 0. That means this two will be coming to here, and it will do the A plus B operation, and here you will have the A plus B, and here it will do the logical AND operation, so you will have the logical AND operation. But S1 is 0, so this will be transferred from here to here, so you will ultimately have the X plus Y. Clear? Same as if it is considered the 0 1, here it will do the subtraction operation A minus B, because you have seen in arithmetic unit when S0 equals to 1, on that moment it will be the subtraction operation A minus B, and here it is S0 equals to 1. For that you will have the logical XOR operation. Now here S1 is 0, so obviously A minus B will be transferred to here, so you can say that X minus Y. So in this way you can design the LU for your 4 type of operations. Okay, so because you have the 2 select lines, okay, 2 control lines, so you can have one for the addition, one for the subtraction, one for the logical AND operation, and one for the exclusive OR operation. So in this way you can design the set, and I hope easily you can design for the 8-bit or 16-bit in the same way. But try to remember, first you design the arithmetic unit, design the logical unit, then you merge these values, and with the help of multiplexer you can try to get the output value. Clear? So do you have any question, better? So today I will send you all the notes. Please, next week within Friday you have to submit all the assignment, whatever I have given.
Ma'am, where do we submit the assignments?
Yeah, that is the question. Then through the module you cannot submit, better?
Ma'am, you would have to like schedule assignments in that case, ma'am.
Okay, I will try to give the environment to you, how to send, how to you will send. Okay, first today I will send you all the notes from the
Okay.
memory design. Okay.
Okay. Ma'am, could we submit our assignments after the after the CA2
No,
exam, because next
no,
week?
no, no. Before midterm you have to submit. How can I understand that which part you are weak? Then I can
Okay,
again
ma'am. Okay,
explain.
ma'am. Okay, ma'am.
Okay, if you can't, then again I will explain.
Okay, ma'am.
Okay. Wait. So today I can stop here.
Yes, ma'am.
Okay, beta.